Hello, this is Brad, and today what I'm going to be quickly covering is the new Seismic Tab that we've added in Mass version 4. It's available for any shear wall design now, where we can specify levels of ductility for using the equivalent static, or for those of you in very low seismic areas, you can use the Simplified Method that is new to the 2015 building code as well. So to get started, I've just entered a new shear wall element here. I'm going to full screen it so that we have it. And now I'm going to put in just a height of 4 meters. You can really put in anything, whatever the size of your shear wall is. And what you'll see here is we have a new Seismic Tab that shows up here. Now, in order for anything to be used in the Seismic Tab, we first would have to apply a seismic load. So I'm going to quickly go to the load stage, and I'm going to apply a load of 100 kilonewtons, fairly high load. And just by default, the first load is dead, so I'm going to change it to earthquake. So now I have a 100 kilonewton lateral point load applied to the shear wall. Like I said, it's a pretty high load. But what I'm going to do now is click on the Seismic tab, and these are all new options. So first of all, if you qualify for the Simplified Method, you'll see the National Building Code of Canada references up here. You can put in your different spectral accelerations and then your different site values, and then what will happen is the software will show right away whether or not you are able to use the simplified. Your values might just be too high in this case, and the software will let you know. But what I'm going to focus on is the equivalent static, which unless you are in Manitoba or Saskatchewan, I think is what most of you folks will be using. So by default with these designs, the basic selection here is conventional construction. So we're talking about reinforced masonry where we have some ductility, so basically the wall being able to absorb some force. If the wall were to have no ductility, that would be unreinforced, and you would see that their RD value that shows up here is equal to 1. I'm going to go back to conventional construction, and this is where you put in your different seismic hazard index values. So what I'm going to do is put in 0.4, 0.2, and let's just say 0.4 here. Not trigger some of these checks, okay? So I filled in these 3 values. The next selection here is which maximum compressive strain is going to be used. So by default, the software will choose that for you. As soon as you go to higher levels of ductility, this value changes from 0.003 down to 0.0025. You can actually uncheck this box and enter in whatever you like. But the software does still check it against limits in the S304, so just be aware of that. You might see some error messages when you start fooling around with that. The next selection here is for the longest wall within your seismic force resisting system. By default, what Mass does is it uses whatever the length of the wall that we're looking at as the longest wall, unless we tell it otherwise, and that is because when we start to get to higher levels of ductility, so I'm going to switch to moderately ductile, this is where you start getting into designs that have a plastic hinge. And the extent of the wall that needs to be designed as plastic hinge is a function of the longest wall. So actually, if I look on my drawing, actually in this case in multi-story, it would show the height. Since we're just looking at an element, we have a warning that shows up here. I do have a post on this as well. It's just going to be linked in the article. But if you were designing just an individual element and it requires a plastic hinge, let's say just for example that the plastic hinge is halfway up the height of the wall. Since we're designing just one element, the entire element that is shown here will be designed using those plastic hinge requirements. There is an option here, which only in the element tab, to basically tell the software this element is not within the plastic hinge. And so that is your way of telling the software, oh, this element that I'm looking at is actually further up the wall and there's masonry below that includes the plastic hinge. And so that is why that selection is there. Otherwise, this is pretty much it. The last selection is when we get into ductile design. So some of the requirements change. Mainly your unsupported height is one of the big things, as well as your ductility verification, minimum steel, plastic hinge requirements, that all changes. And so the software will help you in going through and checking those, where before it was outside the scope of the software. So you would have had to before design it yourself within Mass, but then make sure you satisfy all these other conditions on your own. And so that is just one of the things that we've added to Mass version 4.0. Thank you.